Alright, what's up guys? In this video I'm going to pick up some multivariable calculus, and we're going to be talking about the Jacobian. So we're asked to compute the Jacobian of the following transformations. So we're given the transformations here: x is equal to 9uv, y is equal to u to the 8th minus v to the 8th. And remember, the Jacobian in this particular case, it's the two-dimensional Jacobian. That's just the matrix of those partial derivatives, and then we'll basically find the determinant. So remember the way we do that: we set up our little matrix here, and remember what goes in. It's just the partial of x with respect to u, the partial of x with respect to v, the partial of y with respect to u, and then the partial of y with respect to v. So we'll take the partial derivatives with respect to each of these variables for our transformations x and y, stick them into the matrix, and compute the determinant. That's how we pretty much go about it. So we'll have j of u comma v is equal to, and we're just going to stick the information in here. So we want the partial with respect to u for 9uv. We want the partial with respect to v for 9uv. We want the partial with respect to u for u to the 8th minus v to the 8th, and we want the partial with respect to v for u to the 8th minus v to the 8th. Okay, so we go through and we do it. So remember, when we're taking a partial derivative, we're treating, or in this particular case, since we're taking the partial with respect to u, that means we're treating v as a constant, and vice versa when we take it with respect to v. So that means here we get 9v, here we'll get 9u, here, well, if we use the power rule, we'll get 8u to the 7th power, and then this will be minus 8v to the 7th power. And be very careful about the negative, because this is u to the 8th minus v to the 8th. So we'll treat u as a constant, but don't forget about the minus sign that's there. That's something that'll get a lot of students. It got me like that one time when I was doing Jacobian. So make sure you pay attention to that. Now all we really need to do is just compute the determinant here, and that's pretty much all we really need to do for this. So we know how we do that. We just cross multiply and subtract the products. So 8v to the 7th power. Okay, so this is what it's going to be. It's going to be 9v multiplied by, pay attention to negative signs, very important there, minus 9u times, and I'm going to put it in parentheses even though it's positive, just to kind of, 8u to the 7th power. So looks like we'll get negative 72v to the 8th power, because we this v here is being raised to a power of 1, although you can't see it, and we add the exponents, and then this would be minus 72u to the 8th power. I can factor out a negative 72, and I can write this as negative 72 times v to the 8th power plus u to the 8th power. And that will essentially be the Jacobian, or the Jacobian determinant. So the final answer for this here, u comma v. This can be done when you have 3 transformations, by the way. And I'll post another video with, where we're dealing with 3 transformations. But in this video, we're just going to deal with 2 transformations. So that's how you compute the Jacobian, and that's your answer. So I'll post another video, and we'll continue to work with these. So let me know if that makes sense, and feel free to ask me questions at any time. I'll see y'all next time. Y'all take care.